Hi, my name is Sam, and along with Tyreek and Michael, we'll be looking at exception handling in Python. So, what is an exception? An exception is defined as an event occurring during program execution which results in disruption or failure. Defining and correctly handling exceptions is a crucial aspect of programming. Exceptions are convenient in many ways for handling errors and special conditions. You can raise an exception in a program by using the raise exception statement. Catastrophe can also occur when, in the result of mishandling an exception. So, problem description: on June 4th, 1996, the Ariane 5 spacecraft experienced a catastrophic failure because of mishandling an exception. One bug, one crash was kind of the model used when this happened, and in this situation, an integer overflow led to an exception being handled improperly, which led the inertial navigation system to halt. With a simple test and understanding of how to handle an exception, this could have been the difference between success and potential loss. So in our approach, we will define an exception. For an example, value error invalid literal for ints with base 10. Exemplify the issue the exception creates. Simulate the exception to examine how it could disrupt business. And then exemplify how to control the exception to prevent loss. So for our related work, we can look at one study conducted by F. Christian. I tried to look up his full name, I couldn't find it. So F. Christian, he found that, however, beyond a certain complexity level, it is likely that a system will contain algorithmic faults. These software design faults can and almost certainly will cause system failures. Mark Klein introduced the concept of handling major exceptions by creating a system that evaluates on a basis of responsibility. This is achieved by actively looking system-wide for symptoms of illness and prescribe specific interventions instantiated for this particular instance into a body of general treatment procedures. And then possibly the most famous example of working out exception handling occurred during the Y2K bug scare. In the Y2K bug scare, many believed that every computer system would crash because computers were not built to understand the year 2000. Exceptions and programs were put into place to make sure that when the date hit, January 1st, 2000, nothing would change and computers would continue functioning properly. These rules and exceptions were called year 2000 conformity requirements. So in our approach, we will be, I don't know why it says continued. In our approach, we will be looking at a simple case of what could happen if certain input is not entered properly. In the example, we will be expecting an integer as input. If we are expecting an integer as input and a string is entered instead, then normally the program would throw out a value error exception and it would kill the program if not handled properly. So in the program, while using try and except, we will attempt to store a value as an integer, but if an integer is not entered, then a value error will be caught by the except that we implement into the program, and the program will ask you to try again. So we can have a look at that. So over here we can see the program itself, and if we look right here, this is the try. So in this, we're trying to store a value that we have. So basically, there will be a window, and it prompts you to enter a code, and then whatever you enter as that code, it will store as a value. But it is expecting an integer as the input value itself, so that's why he's trying this. So right now, this is the broken version of the exception handling to show what could happen if you don't perform exception handling correctly. So in this instance, let's say we enter 1563. Since that is an integer, it'll store as a value. But let's say if we entered 1234 ABC, since that is no longer an integer, then it'll come down to the exception area. So in this example right here, this is the broken version of it. So now we're just accepting a generic error. So let's say if somebody was coding this out and they forgot to enter value error, this can show us what will happen if you don't handle an exception correctly. So let's run this. Okay, so now we're prompted with the screen. So let's say proceed to secret key entry. So in here, we can just put a random integer. Okay, and it just says incorrect, please try again. Right, because we're not entering the right one. But it is an integer, so it is at least processing it. So now let's say if we entered something that contained a string. So now if we press submit on this, we get an error. Right here, this is the exception right here. And it says name error is not defined because that's not something that the accept can automatically catch without you having to actually write manually what the error exception or defining what error means. So let's try this again. We'll just put a full string. Same thing. It just errors out on us. So now let's do this properly. So we know that that's a value error since you're entering a string instead of an integer. So let's save this out. So now it's value error. This is the correct syntax for it. Let's run it. Okay, proceed to secret key entry. So again, let's enter just random integer. Let's try it again. And now let's try with a letter to create a string. And now this time, there's no error thrown out on the screen because in the coding itself, now it knows what to do. So if we look here, accept value error. So now, when that value error is triggered, then it's going to prompt you with that text box instead, telling you that it must be an integer itself. So even if we enter a string, same thing, doesn't fit. So that's just a quick way to show you how exception handling helps you create a program that functions properly and handles exceptions correctly. So let's go back to the slides. So our expected deliverable, as you saw, was in the completion of this project, we intend anyone participating in to understand the importance of how to handle and control exceptions. By doing so, you are allowing for cleaner and more efficient coding. And we will provide examples of these types of errors and how they have potential to do a lot more than just end a program you intended to run when actually implemented in business cases. So that was the example we just gave there. Let's say if that was a login field. If you're not allowing strings to be entered as input or something, if you're only expecting an integer for like an access key and somebody enters a string, then we don't want the program to break, right? So in conclusion, we intend to show the importance of proper exception handling and control. Without proper techniques, faulty code can pose multiple security risks. This can range from data leaks, where pertinent data can be displayed in a generic exception that is displayed on the screen, to more catastrophic effects, such as what we saw with the Ariane 5 failure, where a rocket failed because of improper exception handling. So I hope we did a good job of showing that, and thank you.